Okay, let's dive right in. The role of the software engineer is going through one of the biggest, most profound transformations in its entire history. And, you guessed it, it's all being driven by AI. We're not just talking about a little update here, this is a fundamental rewrite of what it even means to build technology.
This one phrase, pulled straight from our source material, it perfectly captures the journey we're about to explore. It's all about shifting from being the person who writes every single line of code to becoming the person who directs and orchestrates intelligent AI agents to do the building for them.
So, is this the end of coding as we know it? Well, not exactly. But here's the thing. AI isn't just another tool in the toolbox anymore. It's becoming a new kind of partner, a co-learner. And this partnership is completely reshaping the entire tech landscape and, the skills you actually need to succeed in it.
Now check this out, because this is where you really see the scale of this change. The research suggests that today's AI technologies could, theoretically, automate more than half of all current work hours. This isn't just about making things a little bit faster. It's forcing a massive, industry-wide rethink of how we work and what skills are valuable. And this slide just lays it out perfectly, what we're calling the Great Skill Shift. On the left, you've got these routine digital skills, right? Stuff like basic coding, information processing, things that are becoming super vulnerable to automation. But look to the right, that's what's in demand now. High-level skills like managing AI tools, writing incredibly precise specifications, and maybe most important of all, exercising human judgment.
So this brings us to the first huge identity shift for engineers. It's a move away from being the person who lays every single brick, one by one, to becoming the architect who designs the entire building, the one who creates the detailed blueprints that these intelligent systems are then going to execute.
At the heart of this new role is this concept called spec-driven development, or SDD. And you can think of it like this. The engineer acts as the architect, writing an incredibly precise blueprint. That's the spec. And this spec is so detailed that a team of tireless AI builders can just take it and automatically generate, test, and even document all the final code. This creates what our source calls a co-learning paradigm, and it's basically this powerful feedback loop. The human provides the vision by writing the spec. The AI executes on that vision, generating the code. And then the human looks at the results and refines the spec. The amazing part? With every single cycle, both the human and the AI get smarter. So if the engineer is now the architect, what are they actually building? Well, they're not just creating static apps anymore. They're designing autonomous digital brains, intelligent, agentic AI systems that can perceive, reason, and act all on their own to achieve goals.
So yeah, that word agentic is really crucial here. What does it mean? It means the AI can go way beyond a simple chat response. An agentic AI can perceive what's going on around it, it can make a plan, it can access tools like APIs or other bits of code, and then it can actually take action in the digital world to get something done.
We can actually break down the anatomy of one of these agents into 3 core parts. First, you've got the brain. This is usually a large language model, and it handles all the reasoning and planning. Second, it has a memory, which uses tech like vector databases to store and retrieve knowledge, not just based on keywords, but on meaning and context. And finally, it has its tools. These are the APIs and subagents it uses to actually interact with the world. And these aren't just small, isolated systems we're talking about. The next-gen engineer has to know how to scale these digital brains. So they'll use technologies like Docker to package up individual agents into these neat, self-contained units, and then use tools like Kubernetes to manage and orchestrate massive swarms of them, letting them all work together at an absolutely incredible scale. Okay, now we get to what might be the most exciting, most science fiction part of this whole transformation. We've built these incredibly powerful digital brains. So, what's the next logical step? Well, it's to give them a physical body, to bridge that gap between the digital world of software and our own physical reality.
I mean, this image just says it all, doesn't it? On the left, you've got that sophisticated digital brain we've been talking about, and on the right, an advanced robotic body. The ultimate goal here is to merge them. This is where software literally meets the real world.
And this quote really underscores just how big of a deal this is. The true potential of AI, it isn't just about optimizing websites or analyzing data. It's about creating embodied intelligence that can perceive, understand, and act in the very same physical space that we do.
So how is this even done?
Well, think of it like building a robot's nervous system. You've got ROS2, which is kind of like a universal operating system for robots. Then you have simulators like Gazebo and Unity, which create digital twins. These are virtual playgrounds where the robot can learn and practice safely before you let it loose in the real world. And finally, you have platforms like NVIDIA Isaac that give the robot the advanced perception it needs to actually see and make sense of its surroundings.
And this brings our whole journey full circle. When you combine the skills of an AI architect with the knowledge of a robotics engineer, you get this entirely new kind of professional. The source material calls them the super orchestrator, someone who can command both digital and physical systems.
And just look at the range of capabilities here. This person can architect AI-native applications from the ground up, deploy them on a global scale in the cloud, and then extend that intelligence into physical humanoid robots that you can actually talk to. They master the entire spectrum of intelligence, from a line of code to a walking, talking machine.
So if you take one thing away, let it be this. The fundamental paradigm has shifted. For decades, the goal was to write reusable code. Now the goal is to build reusable intelligence. Think about that. Instead of creating a library for a customer service chatbot, you architect a general customer empathy agent. That core intelligence can then be deployed anywhere, in a chatbot, an email assistant, or even a physical robot greeting people in a store. That's the difference.
And this leaves us with a truly fascinating question for the future, doesn't it? In a world where AI agents can build our digital infrastructure and intelligent robots can build our physical one, the role of the human shifts from builder to creator, from coder to visionary. So the real question becomes, what will we choose to create?